Hello students, welcome to the Turito School Foundation program. Today we would like to go for that very important topic for the 6th class students. Let's have the look. Yeah, if you are going to have the look into the matter of the problems related to measurement of derived quantities. How do you know about that independent and dependent quantities? If you have taken that one physical quantity which is not at all depending on any other quantity, that is fundamental quantities. If you are looking into that derived quantities, you need to take that dependency. Yeah, you have taken that speed, it's going to depend on the distance covered and the time. Velocity, it depends on displacement and time. So if you want to get a derived quantity, you have to depend on another fundamental on base quantities. Okay, let's have a look into that matter. All right. Yeah, it's very clear. Now we would like to, you know very well why we are going to take this one. We would like to take that one problem based on the derived quantity. That is, you are about to know the calculation of speed and displacement and velocity and acceleration, like that, any of that. We can easily solve this problem. Let's have the look into that. Yeah. If you are going to identify that position of a moving object is going to change that. Yeah, its position is going to be changed. All right, it's very clear. You might be noticed that initial velocity and the final velocity is going to be different. Yeah, you have to see that. At the same time, you need to identify the distance covered. It's very clear. Yes, let's have the look. Okay, you have been identified that. Yes, okay. You can take that initial. Yeah, you have to get this one. Yeah, you can take that initial velocity. It's very clear, that is going to be u. All right, and final velocity. Okay, yeah, it can be identified. So that is v, and you will find out that yes, you can find out that acceleration is equal to v minus u by t. All right, it's very clear, we can solve the problem. Sometimes we after time t seconds, easily you will find out that after time t seconds, you can easily estimate that. What can you say about that acceleration and deceleration? So you have to confirm that you can confirm u is greater than v. That is one case. Okay, you can take this one. This is very clear. Okay. Yeah, you have another case, if it may be u is greater than v. Yes. So you can confirm deceleration. This is the speed or velocity of a particle or a body or a moving object is going to be decreased with respect to the time. As the time increases, what happens? Its speed decreases, let's assume. Then it is going to be in the deceleration. Yeah, very clear. Generally, you would like to confirm as the time increases, the distance covered by that body is going to be increased. It never be negative. It never be decreases. All right. But if you are going to identify that a speed which is going to be identified, that is the speed increases or decreases. the distance covered by the body increases. In case of 1D, just you have to see, as if the body which is in motion, as the time increases, the distance covered by that body is going to be increased, as the time is also going to be increased. But the speed, while you are talking about that speed or velocity, it may increase or it may decreases. If it is increases, it has that acceleration. If it is decreases, it has deceleration. All right, these are all the very good observations. But let us see, it is increases or decreases, we have to decide from this one. Oh, it is increases, it is very clear. The initial speed and final speed, they are going to be verified. Final speed is going to be increased. It is having that acceleration. So, that body which has been accelerated, very clear. So, let us have the parameters, we can solve this. We would like to use this. Yeah, you can take that A is equal to V minus U by T. Yes. And you will find out this one velocity. Just you have to take that velocity and speed. You have to take this one. Velocity and speed. Yeah. So, magnitudes are equal velocity and speed, magnitudes are equal in case of 1D motion. In case of 1D motion, you will confirm that it is 1D motion or 2D motion. If the motion of your body is along one direction, if the motion of body has been restricted to one plane, then it is going to be 2D motion. It's very clear. So, in case of 1D, so just you have to take that. Yeah. While you are talking about that velocity and speed, and you have to get that displacement is equal to distance. Yeah, it's very clear. You have that distance and displacement, velocity and speed, they are going to be, their magnitudes are equal. If you are going to talk about the displacement, it follows the direction. Yeah, we have to take the direction. Let us have the problems we would like to discuss, right? It's very clear. So, as t is going to be increases, d never be less than 0. It's very clear. So, deeply we will discuss about all these parameters, very clear. Right. For 1D. For 1D. Yes, you have to take this one. All these parameters are identified to get the representation. In case of 1D motion, the distance, the magnitude of the distance and displacement, both they are going to be equal. At the same time, we would like to go for that velocity and the speed, their magnitudes are going to be equal in case of 1D motion. It's very clear. Let's have the problems. Yes, if a bike traveling at 20 meter per second is subjected to a steady deceleration. Yes, if you have to get this one, yeah. A bike traveling at 20 meter per second is subjected to a steady deceleration of 5 meter per second square. It's very clear. All right. Okay. How long will it take to come rest? Okay. Let's have the diagram. We would like to go for that. Yes, it is going to be, yes, we have to get this one. Yeah, it has been covered that. Yeah, it is going to be having that initial velocity, final velocity and time t. It has been covered the distance. Yes, it is going to be getting that. This is the case. Yes, steady deceleration. It's very easy for you. You will get that. Yeah. You have to get that steady deceleration. Yes, deceleration. As the time increases, its speed is going to be decreases. Say yes or no. It's very clear. You have to get the deceleration. It's easy for you. You can easily find out that. Yes, you will get this. Yeah, it was in motion. Already it is in motion. We have to find out that some right. Yes. Time increases, the speed is going to be decreased. Decreases uniformly. Just you have to take that. Okay, if it is going to be moving with that 20 meter per second, all right. If it will comes to the rest, it's going to be 0. All right, it is at rest, its final velocity is going to be 0. So, how long will it take to come for rest? It is going to be having that steady deceleration of 5 meter per second square. Yes, you have to take that. That is very clear. The time taken by the body to come to the rest position, if it is going to reach that final destination. All right, you can solve very easily. Write down. Yeah, you know the u is equal to 20 meter per second. All right, and deceleration a is equal to minus 5 meter per second square. We have to take that minus negative sign. V is equal to 0, that is final velocity at rest position. Yeah, it will come to rest. Rest position. It's very clear. You can easily find out that. And you have to find out that t is equal to question mark. It's very clear. 5 meter per second square, it's going to be the steady deceleration. All right. Speed is going to decreases. It's very easy to have the observation. All right. Now you are all going to have the look into that matter. Easily you will get that. We know that formula V minus U by T is equal to A. Yes, you have the substitution. In the given problem, they have mentioned about that deceleration, steady deceleration, and they are mentioned that body which is going to have that some initial velocity. The bike is traveling, it is having that initial velocity. As the time increases, its velocity is going to be decreases. It's very clear, deceleration means that. But how long does it takes to come for the rest position? That is a question, right? You have to take this one, right? You will take that 0 minus 20 meter per second whole upon by t seconds is equal to minus 5 meter per second square. It's very clear and easy, you can identify that. All right. You would like to go for this one, that is, so t is equal to 20 by 5 seconds. It's very clear. T is equal to 4 seconds. Within 4 seconds, it's going to be getting that. It will come to the rest position. If it is going to maintain that steady deceleration of 5 meter per second square, it's very clear. In this problem, you can easily calculate that how much time does it will takes to come to rest position. Easily you will get that. So 4 seconds. Let's have the options. It's going to be 4 seconds. This is the correct option. You can check it very easily. You will find out that. Shall we go for that next problem? Okay. Yeah. Okay. If you are going to have the look into that matter, it's very easy for you. You have been studied about that Rutherford model, yeah, which is going to give the information regarding to that structure of atom and how the electrons are going to move around the nucleus. Very clear. Just have the look into that matter. Yes, you have to get. This is going to be that electron is revolving around the nucleus, and the stability of that electron has been explained by that quantum theory, how it will maintain the stability. Whenever it loses energy, it will absorb energy from that neighboring electrons, from that remaining electrons, or it is going to excite or de-excite. Yes. So, you know very well about that. This is going to be the nucleus. This is nucleus. All right. It's very clear. You would like to get this one. It's very clear. This is going to be Rn. Yes, you are all going to get this one. Rn is the radius of the nucleus. Yes, within the nucleus you will find out that neutron, proton and some other fundamental particles. Just you have to get that muons, kaons and all their fundamental constituents. You have to confirm this one. It's very clear. You would like to get that information. All right. So, from that you are all having that idea. It is going to be getting that. Yes, it is a revolving orbit or radius of the orbit. We would like to get this one. Okay, it's very clear. Now you are going to have that representation, and the simple description about this atom and the stability and how the electron is going to be revolving in its path. So, you have taken one atom and another atom, that interaction. If you have been observing that within the nucleus, its constituents are there. They are going to be in their orbits and their path and their exchange energy. So, you have to talk about that exchange of energy. It's very clear. Okay, what we would like to derive? Here we would like to derive that energy, absorption and emission of energy, absorption of energy. It's very clear. Easily you will find out that whenever that electron which is revolving in its orbit, yes, you can confirm that from higher to lower and lower to higher. Just you have to take this exchange of energy. It has been measured in terms of electron volts, EV, electron volts, and you need to express that in electron volts. Whenever you want to attach, you want to detach that electron, just you have to confirm. So, it is measured in terms of angstrom units, all right, that is 10 to the power of minus 10 meters. How it is going to be microscopic, you have to confirm. At the same time, you need to know that it is measured with 10 to the power of minus, yeah, it is measured in terms of Fermi. Yes, 10 to the power of minus 15 meter. How you are having that magnitude? It's going to be that microscopic phenomenon. You wants to measure the radius of the revolving orbit in case of an electron, the constituent of the atom. You, even though you have been look into that matter, nucleus, its size is going to be very small. That is, the radius of the nucleus is going to be measured in terms of Fermi. That is 10 to the power of minus 15 meter or 10 to the power of minus 13 centimeter. It's very clear. By this one, we would like to go for that. We can solve the problems, right? Let's have the look into that matter. Yes, write the ascending order of the units of the length given below. All right, we would like to go for that. It's very easy for you. You can solve that ascending order. Okay, let's have the look into that matter. That is very clear. 1 Fermi. Just you have to get this. 1 Fermi. In the honor of the scientist, it has been denoted. 1 Fermi is the unit which is used to represent that radius of the nucleus, to represent the radius of nucleus. It's very clear. Nucleus, that is 1 Fermi is equal to 10 to the power of minus 15 meter. All right, it's very clear. Now we would like to go for that micron. 1 micron. Yeah, you have to get that. If you are going to get that virus and bacteria and its size, it's going to be getting that 1 micron. Just we have to think like that. It's a size of the bacteria, size of that virus. Now you can get this one, 10 to the power of minus 6 meter. Yes. What about the third one? Just you have to see angstrom. Angstrom unit. Just you have to take that Fermi, while in case of Fermi, unit to represent the radius of the nucleus. Yeah, atom. It is for angstrom unit to represent radius of atom or size of atom. Yes, that is 1 angstrom unit is equal to 10 to the power of minus 10 meter. Very clear. All right. Nanometer. We would like to get this one. Yeah, you have to take that 1 nanometer. That is going to be, it is also used to represent that the magnitude of that microscopic phenomenon. All right, that is going to be 10 to the power of 9 meter. Okay, if we are having that all, that is going to be 10 to the power of minus just you have to take this one. It's very clear. This one is 10 to the power of minus 15 meter, 10 to the power of minus 6 meter, 10 to the power of minus 10 meter, 10 to the power of minus 9 meter. This is very clear. what we are having, but you have to represent in the ascending order. Just you have to take that. Yeah, what they have given, let's see. Okay, we are going to get this one. Yeah, as you have to seen. Okay, yeah, you have to start from that. Right, 1 by 10 to the power of 15, 1 by 10 to the power of 6, 1 by 10 to the power of 10, 1 by 10 to the power of 9. So you can give that number, that's better for you to give the answer. Yes, if you are going to give that answer, yeah, easily you will find out that this is going to be, you can give the number, this is going to be the first, this is going to be the second, this is going to be the third one, this is going to be the fourth one, as compared to their magnitude. All right, this is going to be the least one. Yes, you have to take this. Yeah. All right, just you have to see, this is very clear, and also you will erase some part. Now you will get the answer, it's better. Okay. Okay, let's see that answer, it's better for you, then you can go for that. If you want to get that, that is 10 to the power of minus 9 meter. Let's go for that ascending order. Yes, so you can go for that. Yeah, you will get that. This is, yeah, you can take that as compared to all. First one is going to be, yes, 1 by 10 to the power of 15 is greater than 1 by 10 to the power of 10 greater than 1 by 10 to the power of 9 greater than 1 by 10 to the power of 6. It's very clear, you can easily find out that. Now you will give the answer ascending order, in the ascending order. So this is going to be that option, you have to take that. This is the first option, very clear. Yeah, it's going to get that. This is third, this is fourth, this is second. So 1, 3, 4, 2. Okay, yes, this is going to be the correct one. Easily you will guess that. Yeah. Have the look into that matter, you can guess that value. It's very easy for you. Yes, everyone get that matter, easily you will find out that. In ascending order, gradually it is going to increases that. Descending order, you will also get the descending order also, very clear, right. Let's go for another one. You would like to discuss about the torque. Yes, you have to get that a rotational force right. While you are going to get that, if you wants to grip the screw, you know very well about that, you have that, it's going to be grip that, yes, you have to get that in the particular direction, right, it's very clear. Yes, to grip into the wood, you have to apply the force in this one. You have to get that rotational force. At the time there exists a torque which has been identified. Torque tau is equal to R bar cross F bar. It's very clear. R bar is the radius vector, just we have to take this one. You wants to get that observation of the torque, just have the look. Yes, everyone has to identify that. Just you wants to get this one. Yes, you have to take that. Yes, everyone has to identify that. This is the torque, we can get that. The rotational force which is acting on one point just to grip the screw or ungrip the screw. It's very clear, you can get that. Torque is going to be generated. You have to consider that rotational force is nothing but torque. Okay students, we would like to confirm these are going to be very effective classes. Please follow all these classes and spread the information to all your well-wishers. Thank you very much. Have a nice day.